Alright guys, welcome to this page of the notes. What we're going to do is talk about our final point of concurrency, which is known as the orthocenter. And the way that you find this point of concurrency called the orthocenter is by finding the point of intersection for the altitudes of a triangle. Altitude is also just really sort of a fancy way of simply saying the height of the triangle. Let's talk about the way this works. First, real quick, what is an altitude? An altitude of a triangle is a perpendicular segment, again, perpendicular segment, that extends from the vertex of a triangle to a line that contains the opposite side. Say, what? Here, let me show you. I've got a diagram right here. Let me draw our triangle in green. So here's my triangle right here, triangle A, B, C. Okay, so I've got my triangle in green, triangle A, B, C. Now, in some cases, the altitude will be inside. It could also be outside, and sometimes it'll lie on the triangle, this orthocenter. It's possible for the orthocenter to be inside, outside, or on the triangle. The way this is really going to work is simply this. If your triangle has all acute angles, all of the angles are less than 90, then your orthocenter will be inside the triangle. If your triangle has an obtuse angle, an angle greater than 90 degrees, your orthocenter will be outside the triangle. So, acute, triangle, your orthocenter will be inside. Obtuse, triangle, your orthocenter will be outside. And if you have a right triangle, your orthocenter will lie on the triangle. Since I here have an obtuse triangle, the way that this is going to work is you just want to extend a couple of the sides of the triangle. Extend the sides of the triangle, which I show here with these dotted lines, right? So I'm just going to extend side AC. I'll just extend it a little bit out beyond the triangle. Same thing for side BC. I extend it a little bit out beyond the triangle. The reason I have to extend those sides is because I know that my orthocenter is going to be outside of the triangle. Now, all I need to do is draw those altitudes. The altitudes will extend from a vertex. They have to come from a vertex, and they must be perpendicular. Must be perpendicular to the side opposite that vertex. Let's start with A. Here's vertex A. I need to draw a line from this vertex that is perpendicular to the side that is opposite A. Well, the side opposite A is side BC. But there's no way to draw a perpendicular line from A to BC that falls inside the triangle, right? That's why my altitude is out here. That's the only way to get a perpendicular line from A to what I've extended BC to be. And the exact same thing here. Vertex B. There's vertex B. I need to draw an altitude from B to the side that's opposite. AC is opposite B. But there's no way to draw a perpendicular line from B to AC unless I draw that line extending outside of the triangle, which is exactly what I did right there. Right? So that's where those two come from. Now C. C, I can, right? From my vertex C, the side opposite is AB. So I'll draw that perpendicular line. But as you can clearly see from the portions of my altitudes I've drawn so far, those altitudes, they don't intersect. Why? Why don't they intersect? Well, it's because I have an obtuse triangle and they're going to intersect outside of the triangle, which means since I don't see them intersecting yet, extend them further. I'll extend this one a little bit further down. I'll extend this one a little bit further down. Extend this one further down, and boom. I found my orthocenter, which we call P, right there where those altitudes intersect each other. All right, so here we go. That point of intersection for the altitudes, like we already mentioned, is what is known as the orthocenter. That is where the altitudes intersect, the point of concurrency for the altitudes. And again, it could be inside, outside, or on the triangle. And we talked about when it will be which. So here we go. Let's try a couple of these. What I've done is I have given you a triangle, and I just want you to go ahead, graph the altitudes, and then let me know where is the orthocenter. Find the orthocenter by graphing the altitudes. Well, I just take a real quick look at it. All of those angles are acute, which means I have an acute, oh, sorry, that's my highlighter. Where's my pen? I have an acute triangle. What does that mean? Acute triangle. Will my orthocenter be inside, outside, or on the triangle? Well, we remember from above, acute means the orthocenter will be inside the triangle. So here we go. I need to draw a line from the vertex to the opposite side, and I just need to make sure that it is perpendicular. Let's see here. I'm thinking that that's going to wind up being right through. Let's see. It looks like, you know what? For freehanding, I feel pretty good about those two lines being perpendicular, and it goes from the opposite side to the vertex. Let's see if I can do it again. Vertex to the opposite side. I need it to be perpendicular. Looks like it's going to run, yeah, right through there. Again, I feel really good about those guys being perpendicular. Looks pretty good to me. And like we said, technically, you really only need to graph two of these in order to find it, but we'll go ahead and do the third one anyway, because we can. I need to go from the vertex to the opposite side, making sure that it is perpendicular, and sure enough, hey, that looks pretty good to me. So for freehanding these, I'm actually really happy with that. I can clearly see where all three of those altitudes intersect, and so my orthocenter in this case, looks like it's at 2, 2, 2, 2. That's where I will have my orthocenter, where those altitudes intersect. I knew it was going to be inside the triangle because it's an acute triangle, and so all of those altitudes have to be inside the triangle. I got another one for you here. Let's try one more of these together before we finish up this section. What I got for you here is another triangle that I have graphed, again, just upon initial inspection. We recognize that this is what kind of a triangle. Of course, I take a look and I notice right there that that angle is larger than 90, so I have an obtuse triangle. Now, because it's an obtuse triangle, what does that tell me? Well, I know that my orthocenter will be outside of the triangle because it is obtuse. What I'll do is extend, right? Let's extend a couple of the sides of this triangle. So I will extend this side right here. I will extend this side right here. And let's go ahead then and draw those altitudes. Now remember, the altitude is going to come from the vertice to the line, this side opposite, and it must be perpendicular. Let's start with the easy one. This vertice right here, I need to go to the side opposite. That'll be this side over here, and it's got to be perpendicular. I feel pretty good . Yeah. Hey, for freehanding it, that ain't bad. I feel really good about those being perpendicular from the vertice to the side opposite. I feel really good about that. Okay, let's do another one then. I got this vertex right up here, this vertex right here. I need to extend it to the side that's opposite, but there's no way to go from the vertex to inside of the triangle and have it be perpendicular. Again, I know that's going to happen because it's obtuse. So that means my perpendicular line is going to be out here somewhere. Let's see here, doing the best I can here to get a perpendicular, oh yeah, Yeah, I feel, well, that's not terrible. I feel pretty good about that. I feel pretty good about that being perpendicular, that those two lines are perpendicular. I can buy that. It looks reasonable to me. So last one, vertex to its opposite side. Its opposite side would be this guy over here. There's no way to go from the vertex to the opposite side and have it be perpendicular unless it's outside the triangle. This one's actually pretty easy. We'll just come straight across. That definitely will be perpendicular. Now, like like we saw before, those altitudes don't intersect. So what I have to do is just extend them a little bit further. I'll extend this one right on out that way. I will extend this one right on out that way, and extend this one right on out that way, and right there we get ourselves our point of intersection. And so all I need to do is count. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. It's at 9, -1. Again, I knew it was going to have to be outside the triangle because it was an obtuse triangle. And so right off the bat, I know I'm looking for an orthocenter outside of the triangle. All right, guys, thank you so much for joining me for this set of videos. We have now gone through all 4 points of concurrency in a triangle. The circumcenter, the incenter, the centroid, and the orthocenter. We've talked about how you find each of those points as well as properties of each of those points. And again, one more time, it can be very easy to mix up these points of concurrency. So please make sure you take your time, go through it slowly, that you understand what each point is, how you find it, and how to distinguish between them. It'll be really, really important that you can do that. So what we'll do is on the next set of videos or notes, we'll go ahead and take a look at what is known as the mid-segment. And exactly what we can do with the mid-segment. Even though it's not a point of concurrency, it still fits well with the rest of our discussion here on triangles. So with that in mind, I'll see you guys next time.